All right, welcome back, everybody, for day 5 of distance learning. Let's see, yesterday I sent you a lot of information about a new transformation called a reflection. Today we're going to continue on with reflections. Yesterday I only kind of introduced reflections using the X and Y axis. Today we're going to get a little more deep into the different lines that we can use, which kind of brings me to the objective here. Objective for the day is to be able to shrink that up a little bit. To be able to reflect images over different lines. So that's all we're looking at today. It's kind of building on what we did yesterday. So let's see, down here it talks about a warm-up. Now if we're going to be dealing in lines, we just got to do a little review of lines. So down here I have some lines in a coordinate plane and asks us to graph those. So the first thing I see is y is equal to 4. Anytime I see that y is equal to a number, I got to remember that it is a horizontal line. It's going to cross at the y-axis wherever the value is, which in this case is 4. So that's a horizontal line that's going to be up here 1, 2, 3, 4. So there's your y is equal to 4. So then I move on, I see x is equal to a number again. When I see x is equal to a number, that is a vertical line, and it's going to cross wherever the number is. Here's at -2, so I got a -2 on the x-axis, vertical line, so this would be the graph of x is equal to -2. Something like that. Then it changes on me, and this is y is equal to x. So this is basically in y equals mx plus b form, where the b is 0 because it's not written, so that means it's going to cross at the origin. Then it has a 1 in front of the x. It's not written, so when the slope is 1, and remember it's written as a slope is rise over run, so it would be a rise of 1, run of 1. So y is equal to x is this. And next year in Algebra 2, you guys are going to be calling that a parent function. But you don't need to worry about that. All you need to know is how to graph it for today. So again, this is the graph of y is equal to x. Then it wants me to do x is equal to 3. So again, x is equal to a number means it's vertical. Again, x is equal to 3 would be over here vertically like this. Then y is equal to -x, so again, that's going to be kind of that diagonal line. The b is 0 again. So again, it's going to cross right here on the y-axis. Now I have a -1 slope. So -1 slope again would be -1 over 1. -1 over 1. So same graph, just going in the opposite direction here. And so you end up with this y is equal to -x. And there's y is equal to -x. Then it also wants me to give the equations for the x and y axis. So the x-axis, remember, is a horizontal line. So anytime I see horizontal, I know it's going to be y is equal to, and again, it's going to be equal to wherever it crosses the y-axis, which is 0. The equation for the y-axis, it's a vertical line, so as soon as I see that, I know it's x is equal to, and it's going to be equal to wherever it crosses the x-axis, which is also at 0. So it's basically the warm. So we'll be using lines and information about lines like this today in our lesson. So in this unit on distance learning, we looked at transformations, and we said basically we're going to take shapes on the coordinate plane and kind of move them around and do different things to them. The first of which was a translation, which is just a slide on the coordinate plane. So we talked about that being a slide, and we could express that in words, coordinates. So slide on the coordinate plane. And then yesterday I kind of introduced the concept of a reflection. Now a reflection, I want you to think of that as a flip on the coordinate plane. So reflection is a flip. So that's a slide. So we can clone this, and this would be a flip. On the coordinate plane. That's a reflection. So we kind of introduced that yesterday. Again, the definition of that, it's a transformation where the image and the pre-image have opposite orientations over lines. Remember that opposite orientation? I demonstrated that with Joey where he had his Stoga t-shirt on. where it said a GOTS in the reverse direction. So that's a weird phenomena that happens with these transformations. Then we talked about reflection is also an isometry, which means that the pre-image and image, even though they're reverse orientation, they're still going to be congruent to each other. So it's still an isometry. All right. So reflecting over the x and y axis. So remember, if I reflected over the x-axis, there was this pattern that formed. So x-axis. There was a pattern that formed, and the pattern was, let's see if I can do this typing. The pre-image point is at AB. Then I could take the image point, and remember, since I'm flipping it over the x-axis, that's changing its position vertically, so that changes the opposite of B. So that'd be A negative B. So then the pattern for the y, flipping it over the y-axis, let's clone that. And then for the y-axis, now when I flip it over that, it changes its left to right, and it makes it the opposite of A. So again, this is the pattern for the x-axis, pre-image to image, pre-image to image. So that's what we looked at yesterday. You guys got pretty good at that from that work that I saw. But today what we're going to do is we're going to find and draw reflection points over different types of lines. To do that, what we're going to do is we're going to use the perpendicular distance. And I'll show you what that means. From pre-image point to the line of reflection. So again, I'm going to show you what that means. But what comes important is this. The perpendicular distance from the pre-image point to the line. So we're going to find that and then use that. So to illustrate that, I have a simple example down here. So once we need to take this pre-image point of point P, where it's just at 2, -1, and once we reflect it across y is equal to 1. So y is equal to 1, I quickly recognize that as a horizontal line crossing at 1, and so I'll draw it in right here. Let's draw it in red. So I'm going to draw reflected over y is equal to 1. Let's find the actual point itself. Point P is at 2, -1. 2, -1's right here. So now, like I said, I have to use the perpendicular distance between the point and the line. So that perpendicular distance that I'm talking about would be this distance right here, which is a total of 2 units. So I'm going to use that on the other side of the line of reflection. So remember yesterday, Joey in the kitchen, his feet were a certain distance from the mirror. And then if you looked into the mirror, his reflected feet are the same distance on the other side. So that same distance would be this 2 units right there, creating P prime, or the image point for P right here. So that is P and P prime. So here, down here, number 2, it wants me to take the same pre-image point of 2, -1, which is still right here, 2, -1, point P, and now it wants me to reflect it across x is equal to 1. X is equal to 1, I quickly recognize that as a vertical line that crosses at 1 on the x-axis, and that is right here. So there's my vertical line and my line of reflection. So again, I want to use the perpendicular distance. So the perpendicular distance, again, is this just as 1 unit, and then I go 1 unit to the other side, creating my image point of P prime. So there's P prime right there. And that is right here. So that's using the perpendicular distance like I was talking about. All right. So next over here, hey buddy. Over here now, it doesn't want to reflect over horizontal or vertical. It's this y is equal to x, which I showed you in the warm-up. So y is equal to x, again, is going to cross at 0 on the, or right at the origin right here. And then the slope is 1, so you have a rise of 1, run of 1, rise of 1, run of 1. So it creates this line right here. Say hi to Joe, everybody. Say hi, Joe. So it creates this line right here. He's going to watch my lesson. So I'm going to cheat and use this line right here because it's really hard for me to draw. So here you can see y is equal to x. So now I need to take this quadrilateral, I'm going to reflect it across, y is equal to x. So again, I still need to use the perpendicular distance. Now the perpendicular distance here, instead of using the sides of those boxes, I'm going to be using the diagonals of those boxes. For instance, if I try to find the reflected point, let's start with B. I'm going to reflect it across that line. I need to find the distance from B to the line. So now instead of counting the sides, I'm going to count diagonals. So again, here's 1 diagonal, 2 diagonals, 3 diagonals to the line. So I got to go 3 diagonals on the other side of the line. So I'm going to go 1 diagonal, 2 diagonals, 3 diagonals, and that's where B prime is going to be. So B prime is happening at -2, +1, 2, 3, 4. -2, +4. Alright, so now let's try to reflect point C. Point C, I'm going to count perpendicular distance using these diagonals. There's 1 diagonal, 2 diagonals, and a half. Do a half, 1, 2. C prime ends up right there, which is at -1, 2, 3, +2. So -3, +2. That is a negative, so we don't lose track of that. All right, so there's my C prime. Let's find P prime. P prime is going to be at 1, 2, 3 and a half, 1, 2, 3. So that ends up in a weird spot, huh? So let's erase these so I don't get confused. So this is P prime. And then my last one here is K. So I'm going to do it again here. 1 diagonal, 2, 3, 4. 1, 2, 3, 4. And that is K prime. Oh, so P prime ended up here. That's at what? -1, 2, 3, and up at 4. So -3, 4 for P prime. And then K prime ends up at, let's see, 1, 2, 3, 4, -5, 1, 2, 3, -5, 3. All right, so let's try to connect those with straight lines. Let's make it look a little bit better. So now you kind of see that reflected image a little bit better there. And I want to show you the pattern that's formed here. So to do that, what I'm going to do is I'm going to show you the pre-image points. So the pre-image points here at B is at what? 1, 2, 3, 4, -2. So this is at 4, -2. That's the pre-image. P is at 4, -3. 4, -3. C is at 1, 2, -2, +2, -3. Whoops. +2, -3. +2, -3. And then down here, excuse me, K is at 1, 2, 3, 1, 2, 3, 4, 5. So 3, -5. So hopefully you found the pattern already. If you look at the pre-image points in blue and then the image points in green, you'll just notice that they're switched. So again, the pattern here is if my pre-image is A comma B,